So, so good evening all. So let me share you my screen. Okay. We are now continuing this course, which is called the DevOps on AWS. So as I told you, it's a 30 hours mentorship, which can go up to 35 hours also, depending upon your doubts and all. And in which we have 20 real-time projects with which you'll be getting 3 years of experience. It's a job-ready course. So as you can see, we have so many projects here. Some we have major projects, under which we have some minor projects. So we were doing this module 2. As I told you, module 1 is theoretical part. So we will be continuing with module 2. And don't worry, we are not doing anything in sequence, but you will learn each and everything. Because module 1 is generally all what do you call, like it's theory part. So this you will learn as you do your practicals, you will understand more. Like if I start the theory part, it won't be interesting, right? So let us continue like that. Okay, so we were doing this project, which was migration of a web application from on-premise to public cloud. Okay, so this was the architecture which I showed you yesterday. We had some applications or devices which was on-premise, and we were trying to migrate it to the VPC, a private cloud, virtual private cloud, where we will create servers. So this was the architecture. Then again, I created one more architecture, which was this. So for this, we have to create this VPC. So today we will learn to create VPC, and we will know what is public subnet, what is private subnet, and how subnets are created. So today we will learn all these things. Hope you all have created your account in AWS. So this is the AWS management console, as I showed you yesterday. Now, when you go to services, just click on services. There are a lot of services here provided by Amazon. Now, if you want any services to be highlighted, just you can give star. Now, if I remove star, you can see it is removed from here. So what you can do, you can just star it, and when you do star, also you can just understand like this. In WhatsApp also, if you stare anything, you get it very easily. So this is the same thing. If you need something, or like if you're using it continuously, so you can stare it. So I stared it and I got my VPC here. Now you can click on VPC. So I'm creating a VPC for you now, but after the class, please create a VPC for yourself. Here are the regions. I told you, here are the regions. So there are 64 availability zones, and we have 21 regions altogether where we have the data centers. So in India, we have one, which have 3 availability zones. So region is nothing but the physical geographical location. And what do you mean by availability zone? That is the AZ. It means any user from any part of the world can access the services. So regions are designed as such, like it is isolated, one is isolated from another, so that we can achieve scalability. So these are very safe. Like these regions are kept under surveillance 24/7. The integrity and authentication of your data is maintained or not, it is checked continuously. So your data is secured and monitored properly. So you are safe in this case. So let's create a VPC now. So we'll just click on this orange button, which is create VPC. And see, the console look like this now. So we will just select VPC only because we are creating only one VPC. So we will just select this VPC only. Now you can name anything your VPC. So let me name it as LWPLabs VPC. Now what is CIDR? Here you can see something is there as CIDR. So this IPv4 CIDR, it is asking one range of IP address. So to understand this, you need to understand something as means like you can understand like this. Let me give you an example. Let me show you the diagram and just explain. So CIDR means how much square feet you require to be when you buy a flat. So first thing we think is, okay, we need 1,000 square feet of flat or maybe 1,800 of square feet. So how much square feet you need, it depends on you. So similarly, when you move from on-premise, so when you move from on-premise, like when you see this diagram, when you move from on-premise to cloud, we need to understand how many IPs you require. So here we have 300 IPs. So here also we need 300 IPs. So I think this is clear. The IPs which we have in on-premise is what we need in this cloud, the same IP here. So we have the same architecture in the cloud also. So we need 300 IPs there also. Now we need to find the CIDR. Now this CIDR we need to find. So there is one document. I will give it to you. This document, let me open the document. So this is a network document. Here you can see you have some ranges here. Can you see that? So what IP means? Internet Protocol Address. Total, this many IPs are there in the whole world. You can see the range is 0.0.0 to 255.255.255.255. So this is a total range you have, the IPs. Now, these are divided into some private IPs, some public IPs. You can see now, so it will start from 00 to this. Like this, inside this IP range, we have some reserved IP, private IP. So this is a Wi-Fi IP. So these are private types and this can be used by any companies. So just see, these are some private IPs. So you can see the ranges start from 192 to 00, from 192 to 255, 255. So see the range, now anything you can take in between this. So anything in between you can just choose for private IP. So in whatever company you are, you'll find the range of the private IPs this only. So from this, what did you understand? We understood that we have some reserved private IPs which can be used by companies. So these are reserved private IPs. So in this range, I'll have this many IPs. In this range, I will have this many IPs. And in this range, I'll have this many IPs. So total range is this much. So rest all are public. What all are left are public IPs. So these two IPs are public IPs. So this IP, no one can use. You cannot use this IP. Now, if one person is using this IP in the world, that means that is dedicated to him. Unless and until he will release it, no one can use this IP. So now if I type, if you go to browser, and if you type here, what is my IP? You will get your IP address. So this is your IP address with which you have been connected. So this is the public IP. This is unique to me and no one in the world can use this. So this IP Let me go to the network docs again. So this IP is private range. So this is my device IP. This browser, which I showed you, this is my device IP. So this many IP you can create in this private IP. Okay. Now, if I ask you this IP, which is, let me just write down, it is 10.1.2.3. So can anybody tell me, is this a private IP or a public IP? Can anybody answer this? You can see the network doc also. Are you understanding the thing? Yes, someone was answering.
That one public IP, I think.
Just look at it again. Just see this again. So I've given this IP 10.1.2.3. Okay. So what is this?
Private IP.
Okay, this is private. So you understood this. These are reserved private IPs. So you have to select from these IPs. And this is public, which is a unique IP. These are unique IPs. So now this, I think this is clear to you. Now here I need the IP cider. So here I need the IP cider, which is proportional to how many IPs I want. So if I go to my diagram, you see, I need 300 IPs here. So I will go to this network doc, and here I will find the cider for my 300 IPs. So it depends. You can have 300, 400, 600, depends on you. So we will just take an example for 300 IPs here. So it is nothing. If you see, it is nothing but the IP/X, which is called the prefix. So this is called the prefix. So we need to find the prefix. We will select one IP. So it should be private. So you can select any IP. So maybe I have selected this IP, 10.17.0.0. You can select any from this range. You can select this range also, this range also. So anything you can select. Now you have to find this X, which is the prefix. So out of this private IP range, we have to consider one IP range. So I told you I selected this. So all my computers will have this range. And after slash, this is something we have to find. So this is called prefix, as I told you. So we have to calculate X. We will do simple mathematical calculation. So first decide IP of your VPC, which should be private IP. So we have decided this should be a private IP. Because VPC is virtual private cloud, means we are migrating 300 devices to cloud. Here we will do, see, now, how do we calculate X? Now, we have to calculate the value of X. We have 300 IPs. So how will we calculate? So see, we have to do 2 to the power of 0. Now, just look at this. Each decimal place is of 8 bits. So see, it comprises of 8 bits. So 8 into 4 is equal to 32. Okay, so we have 32 bits in one IP address. So what we'll do 2 to the power of like 0, 1, 2, and we get until we get the value which is greater than this 300, right? So we'll start from 2 to the power of 0, which is equal to 1, then 2 to the power of 2, 1, which is 2. Now 2 to the power of 2, which is 4, 2 to the power of 3, which is 8, which is a no. So this is also a no. This is also no. And this is, as you can see, these values are less than 300. Now, you can continue like this. Now, 2 to the power of 7, which is equal to 128, which is also less than 300. So this is also no. Now, 2 to the power of 8, which is 256, which is also less than 300. Now, we'll do it to 2 to the power of 9, which is 512, which is a yes, which is greater than 300. So we will take 2 to the power of 9. Now, 32 minus 9, which is 32 bits, I told you, 32 minus 32 bits, 32 minus 9, the power of this, we will do and we'll get the value of this prefix. So we are getting the value of 300 IPs, which is greater than 300. So we will get directly 300 because we are getting multiples of 2 to the power. So we are getting to the power of 2 to the power of 9, which is 512. So we will do x is equal to, here, let me write, x is equal to 32 minus 9, which is equal to 22. So this is the value of my cider. So I will just copy this value. I'll just copy this value. I'll go to my console and paste it here. So I have this value now. So my cider value is this. And if you want, you can add some tags also. So tags are something like these are something information, like if you put some tags, you will know that like in companies, there are a lot of VPCs. Like for lab purpose, you're creating one. But maybe when you're working in a company, you have a lot of VPC. So you can tag those like why this VPC is there. So you name it, then you can give the value. So like this, and you can add more tags from here. So now we will create the VPC. So we got this VPC. We will go to your VPC. So one default VPC, when you create your AWS account, you will have one default VPC already there. So you can use that also. You can create as many VPC as you want. So see, I have created this VPC now. And now the status it is showing is available. IP4 cider is this, the same which we have calculated here. So you can see all the details here. Okay. So if you scroll down here below also, you can see all the details. Now we have some settings to do here. So now after this, if you see this diagram, yesterday I told you your VPC can be divided as many subnets as you want. So if you have one server, you can imagine if your server is down, all your work will stop, right? Now Flipkart, Flipkart, Amazon cannot afford to do that. They cannot stop the service. Like if there's any problem in the server, so that they cannot stop it. The customers will be diverted. Wait for a second also. So that is the thing. Like 2 or 3 servers in another availability zone. So maybe this subnet, so we'll divide it into 4 subnets, which is public subnet 1, public subnet 2, and private subnet 1, and private 2. So this public subnet will be maybe in AZ1. This private will be in AZ12, and this second one will be in AZ2, and this in AZ. So we have divided this into 4 subnets, which are in different availability zones. So let's create this subnet. We'll go to the console. And on the left side, you see under VPC, there is an option which are subnets. So we'll click on subnet. Here we just click on create subnet. So you have to, so when you click on create subnet, you will get this type of interface. Now you will select the VPC with which you want to make the subnets. So this is my VPC. which I created now. So this is very important. You have to select this VPC very wisely. If you select a wrong VPC, you will not be able to proceed. So now see, can you see that there are some subnet settings? So they are asking subnet 1 of 1. So you can just, now we have to calculate this subnet CIDR. See, there is, you have to give the name, the availability zone, and also the CIDR. Now you have to calculate the CIDR also. So to calculate subnet, we can just go to this document again. Now, if you scroll down, so if you see in the diagram, we have 4 subnets, right? So we have to calculate here for 4 subnets. So I have given here subnet is equal to 4. You can also have 2 subnets. You can give 2 subnets also. Now, again, the same procedure you have to do. Now, you will do 2 to the power of 0, which is 1, 2 to the power of 2, which is 2, and 2 to the power of 4, which is equivalent to this 4 subnets. So we have 4 subnets, which is 2. So what we'll do, we will take this CIDR. So this CIDR of VPC, what we have calculated this prefix, we'll add the subnet, this value of subnet, which is 2, to this prefix. So now 23 plus 2, which is 25. So this is the value of the subnet. Let me delete this. So now we have the value of this subnet. Now we have created 4 subnets, right? But we are getting the value of only 1 subnet. So now you must be thinking, you may be thinking, how will I get the value of 4 subnet? Because each subnet will have their own value. You cannot put the same value there. See, when you do subnet 2 out of 2, again they're asking for the CIDR block, the CIDR block. So you can call it CIDR. Many of them call it CIDR. So you can call it anything you want. So now if you add another subnet, see it's asking another CIDR block. So what we'll do, we have something as IP calculator. So first we will just copy this and paste the first value of this IP CIDR. So let me name it as PB1, which is public subnet 1. Now, preference it's asking, so you can give 1A. So I'm choosing the availability zone as US East 1A. Now you can paste that IP CIDR which we have copied. So this is the value of first subnet. Now we will move to subnet 2. Let me name it as PB2. Now, can you tell me what should be the reason here? Should I select US East 1A or 1B or 1C or 1D? Can you tell me? What should be the region I should select for PB2? If you want, you can see the diagram as well. See, this is the architecture, and we have public subnet in AZ1, public subnet AZ2. So what should be here, the availability zone? Can you just give an answer for this? Okay, so I think I should tell you. So this should be US 1B, or you can choose 1C or 1D. There should be another availability zone, because if you go to the diagram, you see here I have given for public subnet, the zone is this is a different zone, and for public subnet, it is a different zone, so that you have higher availability. So I have chosen this. Now, I need to have this IP4 CIDR block. Now we have to calculate it. So you will go to the browser and you will type here IP calculator. So this is a subnet calculator. So I don't need this. I just go down. So this is the IP calculator. Here you can just calculate the value of your CIDR, the 4 subnet. So I will give here the address. So I will go to my document. So I will take this VPC IP address, which I have chosen. So I will just copy this. I will go back to the browser and paste it here. So this is my VPC IP address. Now, what is the prefix for VPC? So if you see, it's 23. So what we'll do, we'll give 23 here. Now we are moving from 23 to 25. So our subnet value is 25. So now we'll just click on calculate. So see, if you scroll down, you can see you have 4 values here. 1, 2, 3, 4. So you have got the 4 value. Now you can just copy this. So I'll just copy this value. Go back to browser and paste it here. So this is the value of my second subnet, which is PV2. Now I will create another subnet, which is my private subnet. So I will name it as PV1. What should be the preference zone? Now, can you answer this? What should I give the preference zone? What should be my AZ, the availability zone? Come on, guys, this is very simple. You can answer.
1B.
Oh, why 1B? See the diagram again.
Is
See the
1A.
diagram. Yes, Doris?
1A.
Right. So we will just choose 1 and we'll copy the CIDR, the third CIDR, which we have calculated. So this is my third CIDR. And we'll paste it here. So see, I have got the value of 3 subnets here. Now I will create a 4th subnet, which is hybrid subnet, the 4th subnet. Now the preference zone I will select is 1B because this is in 1B. See, I have one public subnet in one zone and private in the same zone, and the other in the same zone. The public and the private in the same zone. So I'm selected 1B. What I selected for public, I selected for private. So I will just copy the value of the 4th CIDR. So you will copy this, go back to VPC, and just paste it. So done. So see what we have done. I will tell you again. So you have to create a subnet where you have to choose your VPC, which is very important. Don't ignore this. So you have to select it very wisely. Then you have to create the subnets you have selected. How many, like you can also have, I told you, 2 subnets, one private and one public. But here we have chosen 4 subnets. So out of 4 subnets, 2 are public and 2 are private. So the first one is in the availability zone, which is US East 1A. Now the second PV2 public subnet is in US East 1B. Subnet 3, which is my private subnet, is in US East 1A, which is the same as this public, the first public subnet. And the 4th subnet, which is in the availability zone, which is US East 1B, same as PV2 for public subnet 2. So now you will just go and create subnet. Okay. So it's saying its address overlaps the existing subnet CIDR is So let's check. Let me open it in a new tab. So let us check if this the VPC which we have before is same as this. The CIDR is same as this or not. We go to the VPCs. So we go to subnets. So it's showing the subnets is same here, right? So what we can do, we can change the value of this VPC. So we can select another IP. So what you can do here. So this is overlapping, right? CIDR address overlaps with existing subset IDR, subnet CIDR, which is 10.17.05. So this is the same, it's saying I have the same IP, I have the same subnet here. So what we can do, we can just change this. So what, let's go back. Let's go back and we can go to the VPC. We can delete this actions and we can delete this VPC because the CIDR is saying the same. Okay. Now let us select another private IP for this. So you can select here. So I will take this range, right? So I will take this range, copy and paste. So I have chosen another private range. And if I go to my VPC, let me see if the default VPC is here, which is 172. So it's not overlapping, right? So I have chosen this. Now you have to calculate again. So wherever you have this, just paste this IP. Now we can change the IPs also. Let it be 600 IPs. So we are checking for 600 IPs now. So this is also no now because this is not calculate to R of 10, which is equal to 1024. So this is yes now. So we have 10. So we will just deduct this from 10. Now the value is 22 here. 32 minus 10 is 22. Now, when you add this, so this is 22. Now you add 22 with 2. The subnet value is 24. So this is a value. Now we'll just copy this value. We'll go to VPC again. So you can name it as LWPLabs, VPC. You can copy the CIDR. So I have pasted the CIDR here. Create VPC. Right? 24 was a subnet. So let me check again. This is the right value. Giving error to give this error. We have selected the private IP range. let us change this to maybe 18 or something, because the IP range is here till 31, right? So let us change and see, maybe this is a border, it's not thinking. So let us change it to 18 here. So it's 18. This type of errors you will get, don't worry. While creating VPCs and all, like you have many VPC, this type of error you will get. So you don't have to worry about that. Any errors you will get, this will be a learning for you, remember. Saying must be a valid IP. Why it's giving so? See, there was a space here. I deleted the space here. Now, if I go to create VPC, it has been created. So spaces are very important. You have to see what happened. I have a space here. Here, I had a space, see. So I deleted the space, and after that, I could create this VPC. So my VPC has been created with this value, which is 17.18.00.22. Now we will create the subnets. So create subnets. We select the VPC, which is LWPLabs. So PD1. So you can go to the IP calculator again, once again, and you can just paste your CIDR here. And this is from 22 to 24. Now calculate. This is 18, I suppose. Okay. So you will get the value. So you will just copy the value, the first value from here, and paste it there on your VPC. Add a new subnet, which is PV2. Stability zone being 1B. And the CIDR, you have to copy again. So this is the second value. Go and paste it here. Add a new subnet. So now I'll just create my PV1. Availability zone 1A. The third CIDR value. Subset again. So it's PV2. Reference zone is 1B. Now the value, the fourth value, just copy it from here. So copy and paste it there. Okay. So now there is no mistake. So see, the subnets are being created. Can you see that? If you go to subnets, so see, your 4 subnets are available, being the VPC of LWPLabs, the IP CIDR you can see here. So this is how you will create your subnet. Now let's go to the diagram once again. Now just look at this. Just by giving the name public and private, it will not become public and private, right? This is a portal. And if these two regions are public, these two regions are public, and these two regions are private, so there should be some watchman. Okay, so he won't allow anybody to come inside. So there should be some rules. So that rule is called the route table. So there is something like route table. So we will create now route table. So there are two types of route table. One is public route table and one is private route table. So what exactly we are doing, we are creating this VPC, which is private cloud. And in that private cloud, we are creating 4 subnets. You can also think it's like 4 rooms we are creating, where two rooms are like drawing rooms or storeroom, where anybody can enter, and 2 private subnets, you can think it is like your bedroom. It's where nobody can enter. So if you remember these examples, I'm sure you won't be mistaken. So just think these are like drawing room and storeroom, and this is your bedroom. Now there are 2 route tables, one public route table. So we have 2 route tables, which is one route table which is in our public zone and one which is in our private zone. So now this is public, as I told you, route table, and this is private route table. The public route table will monitor the public subnets. So this will monitor these public subnets, and this will monitor these private subnets. So let me just write it down here. So this is my public route table, RT, and this is my private RT. Okay. So this monitoring is called the public subnet association. So this is called the public subnet association, and this is called the private association, subnet association. So let's go and create the route table. We will go, and again on the left side, you can see there is an option which is called the route table. We'll just click on this. So here you can see there is a route table automatically created. This one I have not created. Now, if you go see, there is a route table which is attached to this LWPLabs. So this route table is automatically, this is called the public route table. This is automatically created. So we will just name it as public route table. So this is, I told you, automatically created. You don't have to create this public route table. So this we get free when we create subnets. So when we created this VPC and subnet, this public route table we got automatically. Now let's create one more public route, private route table. So here we'll name it as PVRT. So we are creating one more route table, which is a public route table. We'll select the VPC. So this is our VPC. So see, VPC is very important. Everywhere you have to select the VPC, because everything what you're creating is inside the VPC. See the diagram. Whatever you are doing is inside this VPC. So your VPC is very important. Everything will ask, whatever you create, they will ask for the VPC, details of the VPC. So we have created one more private route table. Now let us go to route table. Now here you can see this is a private route table which we have attached with the LWPLabs VPC. Now here you can see there is something as subnet association. So if you click on this subnet association, let me just So see, it's showing there is no associations here. So we will just, what we'll do, we will just click on edit subnet association. And what we'll do, we'll just select on public, these public subnets of ours. So this public subnet will be attached to public route. So what we are doing, we are attaching this public subnets to public route. So save association. I will continue to show you this diagram. So see, this public subnets are associated with this route table. So this is what I did here. I just associated. Now, if you see the association, you can see this is interlinked with this route. Right. Now, what we'll do, we will, as we have created one more private route table, we will just select that and we'll go to subnet association. So see, again, it's showing nothing here. No associations are there. So no associations are there. Now we'll go to edit subnets association. Now we will select the private subnets. And save associations. So now we have associated. Now, if you see here the details, you can see the private route tables are associated with two subnets, which are private subnets, and the public subnet, public route table is associated with two subnets, which are public subnets. So this is called the subnet association, which I was talking about. So public and private, hope you have understood this. This is very simple. Now, I will repeat once again. So we have told this public route table to manage public subnets and private route table to manage private subnets. But we have not set any protocol or rule for it. It's so far that we have to create these rules, route rules. Okay. So by default, whenever we create a route table, one local rule is automatically created. Now, tell me why this route table is there. Why this watchman is sitting here? Can you tell me why this watchman we have made to sit here? Why it is sitting here? So I told you the whole story. You're not able to answer me. Why we have created this route table?
It's to create rules that will monitor the subnets.
Yeah, right. And also to prevent the access. So there should be some rules to the access, right? So for example, somebody comes in the hotel to eat. So you will not allow his entry directly to the private room, will you? If somebody is coming to the hotel, you will not, or if somebody is coming at your place, you will not directly take that person to your bedroom. You will first make that person to sit in the drawing room, right? So this is the same thing. So to go to the private room, like in the hotel, we should show some pass or have some permissions for that. So what is a local route? So it is like local routing is what, like inside a VPC is every service can talk to each other. Like at your home, if you have your Wi-Fi and your mobile and TV is using the same Wi-Fi. So can you pass mobile to TV? Yes, you can do that. But if your mobile is having your mobile network and TV is having the Wi-Fi network, then it cannot be casted because they're not having the same network. So this is the thing. So this is like a Wi-Fi inside or VPC or local network where you can connect with each other. So these can connect with each other easily. Okay. But I'm talking about outside. I'm talking about outside people. That there should be some rules for the outside people because, danger is outside. So this is called internet. So we have something as internet. So we are going to connect with internet. So someone who is coming from outside through internet, how will your VPC react? So that is a concern. So there is one thing which we will understand. There is something which is called the internet gateway. So we have something as internet gateway, which is also called as IGW. So this is the internet gateway which we will be having here. So any person coming from outside, which is through internet, so the IP for internet is this is the two-way flyover. So anybody can go outside and anybody can come inside. Now this is called the internet gateway. Also, this internet gateway, that is IGW, you have to attach it to the subnets. So now let's create an internet gateway. So we will create an internet gateway and we will see which subnet we will attach it to. So let's go back to our console. Now we have something as internet gateway on the left side. If you see index, there is internet gateway. So see, I will just create an internet gateway here. So I will name it as LWPLabs IGW. So I've created an internet gateway. Once you have created an internet gateway, you can see it's in the detached mode. Can you see? The rest of mine are attached, but this is in the detached mode. So this is like, it's open now. So you need to attach it with the VPC. So we will go to action. First, we will select this and we'll go to action. There is some option which is called attach to VPC. You will select the VPC. So see, I told you VPC is very important. You have to attach everything with the VPC. So now if you go to internet gateway, now the status is showing attached. So you can see, now you can tell your watchman here now that this is your public route table and that anyone coming from this gate, which is IGW, can come directly to the subnets. Which subnet? Public subnet. But not more than that. It cannot move to private subnet. It is allowed only to come to the public subnets. So through IGW, which is in place as well as egress, so they can only come until public subnet, not more than that. Now we will go back to our console, go to route table, select the public route table, and go to action. Edit routes. So see, here you can see there is only one rule. I told you there is a local rule. What is the local rule I told you? Like you can, everything can talk to each other. This is inside, there is a local rule. So here you can see it is showing a local rule is automatically created. Now what we'll do, we'll create another rule, which is internet. So IGW, and we'll select this internet gateway. So this is the internet gateway which we created. Now you will save the changes. So internet gateway, we're going to select this, save. So we have attached this gateway to this route table. Now you have one more rule, this you will do to the public route table. Now there are how many route tables? If you see, we have created two route tables, one public route table and one private route table. So at public route table, we have done this to we have connected this internet gateway to this public route table, right? So always remember, you have to attach internet gateway to public route table. Just you have to understand the theory. If you understand things, you can do. I'm sure you can do it. So you should understand this architecture. That is why we were saying these architectures are very important. If you just understand these architecture, we are sure you will do it. So if you understand this concept, why this route table is created, why this IGW is needed, we can do that. So we'll go to the console again. So there should be something for private route table as well, because we cannot attach this private route table to IGW, which is internet gateway, which will be a blunder you will be doing. So now a question may arise in your mind, why we are studying this network concept. Now, sometimes some companies from outside, they want to do audit or something like in your VPC. So they can also go, you can also download files or you can update things. So they can send a script to see how compliant you are. So you should have, so maybe there is something like patching and all they want to do. Some company, they want to do some patching and all. So you should also update your software time to time, because the company will see how old is your software. So for that, you have to apply patches, as I told you, time to time. So egress should be allowed, but ingress should not be allowed. So this should not be allowed from private subnet. This is not allowed. So this is not allowed. But ingress, sorry, I'm so sorry.
It's the other way around.
Yeah. So this ingress is not allowed. Egress is allowed here. So from private subnet, sometimes someone can go outside, but no one can come inside. So you need something here. Like IGW, you have for public subnets, here you need something. So which will allow to go outside, but will not allow someone to come inside. So with the help of NAT, so there is something as NAT gateway. We can attach it to private route also. So where should the NAT be created? Should it be created in private or in public? So a NAT gateway will be created in public. So we will create a NAT gateway . Why will we create NAT gateway in public? So we were talking about private. You must be thinking why we are creating this in NAT public subnet. So because you need internet for that. Because private subnet is totally different. We have no internet. So what will happen? This IGW, this NAT gateway will use this internet, and in return, it will use this private subnet will have this NAT gateway. So because if NAT gateway does not have any internet, how will it allow the database or Oracle to go outside and connect with outside world? That is to the Oracle database and apply patching. So how will it do this? So how will it go out without internet? So only outside is possible, inside is not possible, as I told you. Am I clear? Now let me. So this is done. Now we will go and create the NAT gateway. So let us go and create the NAT gateways. So if you scroll down, you have something as NAT gateways. Okay, guys, just give me a So I was talking about NAT gateway. So we will be creating NAT gateway. Now, what will happen? We will create two NAT gateways. If you go to the diagram here, one NAT gateway for this private subnet and one NAT gateway for this private subnet. So we will have two NAT gateways here. Now, if this NAT gateway goes down for some reason, what will happen? Your server will also go down. So you cannot apply patch. So we have to create two NAT gateway in two availability zone. So both your NAT gateways should be attached to your private route table. So IGW is something which is attached to the whole VPC. But NAT gateways is like a server which will be attached to the private route tables. That it is attached to the route tables, to the subnets. So it should be attached to both the subnets mainly for applying patch. So this is how you should design your architecture. NAT gateway 1, NAT gateway 2. So we are having two NAT gateways and we will attach the NAT gateway to the private route. So do we need two IGW? No, we do not need two IGW because these are not attached to the subnets. This is attached to the whole VPC. So this question you have in the AWS certification. So you should have this enough logic to answer this question. Okay, so guys, now it's already 9:10. So I suppose I will just end my class here till we meet tomorrow because we have another class to continue. Hope you have understood what I have taught you today. Okay. So let's meet tomorrow for another class.